Hello everyone, my name is Yeyue Chen, going by York. I'm presenting here to apply for the application engineer position in Rochester in QVI. I'm a senior at the University of Rochester, and this is my 5th year in Rochester. I really like this city. I major in optical engineering with double minors in maths and mechanical engineering. Through my experience and academic achievements, I'm confident that I possess the skills that will make me a successful team member of QVI, a global leader in optical, mechanical, electronic, and software technologies for vision and multi-sensor measuring systems. Through my coursework, I've developed a deep understanding of optical engineering principles, including lens design, electromagnetic theory, interference and diffraction, sources and detectors. In addition, I have a lot of experience of using MATLAB and Wolfram Mathematica to program for engineering projects, using Pro Engineer as a CAD drawing tool for mechanical engineering design, and using Code 5 and ZMax for optical lens design. I was a lab assistant in the circuits and microcontrollers course for over a year, and I also served as teaching assistant for some optics courses. Because of my outstanding performance in optical major courses, I won an opportunity to re-edit a textbook called Modern Lens Design with Professor Julie Bentley. I introduced different optical design forms such as doublets, triplets, eyepieces, and etc. Meanwhile, I also participate in the task of re-optimized lenses to recover EFL and performance. Instead of an all-inclusive introduction of my experience in optical engineering, I would prefer to tell several key projects I completed in the past. The Optical Engineering Senior Design Project was a year-long major required course for graduation. In this course, our senior students were required to apply for and complete actual projects proposed by local optical companies. As my team's leader and project coordinator, I was not only responsible for the overall administration of the project, but also in charge of the optical lens design by using Code 5 and assemblage of our telescope prototype. The telescope prototype we designed featured an off-axis single mirror for planetary observation with a camera instead of an eye. Since the design's main objective was to stimulate young children interested in astronomy and optics, the telescope should be able to be operated by children 12 years old of age and older. A mechanical pointing system should be able to place naked eye planets in the field of view. The construction of the telescope was required to be simple enough that most supplies can be purchased at the home improvement store. Another worth mentioning project I completed during undergrad ages was a short-throw projector. When we give presentations, especially in a classroom, we often use a projector to cast our PPT or PDF on a screen. This traditional way of projection has two obvious flaws. First, the speaker is blinded by the strong beam of light from the projector and cannot see the class. Second, shadow cast by the speaker would cover important slides content and thus confuse the listeners. To solve these problems, we designed our short-throw projector. This normal lens design does not cast shadows on screen and avoids the speaker's eyes altogether. In 2014, I worked with my teammates to conduct an optomechanical ultrasonic transducer research. In this project, we compared traditional ultrasonic transducers with optomechanical ones, with the advantages of optomechanical effect Certain ultrasonic signal will change the displacement difference of the edge between two disks, resulting to an optical resonance shift, which will change the optical output. Using this principle, we realize the sensing of certain ultrasonic frequency. Unlike many of my peers who are only interested in doing research, I also like the application and commercial values of my major's technologies. My summer internship in Bennewick has largely satisfied such curiosity. As a high-tech startup, Bennewick focused on the research and development of 3D ranging lidar, which possess wide variety of applications such as auto avoidance, terrain following, simultaneous localization and mapping, also called SLAM, and HD depth perception for drones, robots, and driverless cars. I first worked in the research of the TOF chips, the core technology of 3D LiDAR. As I understood the working principles of the product, I was asked to make a promotional video of the company's newest product. At the end of the internship, I received return offer from Bennewick and a reference letter written by its CEO. Currently, I'm still working part-time for this company as a marketing assistant to develop its North American markets. Particularly, I'm responsible for the promotion of terrain following LiDAR, also called TF01, for plant protection drones in various workshops and trade shows with the product's demos. I'm currently enrolled in Rochester's Kaufman Entrepreneurial Year Scholars Program, which was a highly competitive program providing qualified students with full funding for an extra year to complete an entrepreneurial project and study related courses. This project has no bearing with my optics major, but it does diversify my skills in other areas. As an applicant for QVI's application engineer, I will use the skills that I have learned through my academic and work experience to be an asset on the team where I'm placed. I will employ my work ethic and lab skills to be an efficient member of the team and utilize my creative abilities to offer valuable input. Feel free to call me at 585-489-0776 or email me at ychen121@u.rochester.edu. Thank you for your time. I look forward to an opportunity to show you how I can benefit your team.